The concept of a human electrical circuit raises interesting points about the body's conductivity and interaction with electricity. While the provided context does not offer specific details about the longest human electrical circuit, we can discuss general principles. The human body is a conductor of electricity primarily due to the presence of electrolytes in bodily fluids. These electrolytes, such as sodium, potassium, and chloride ions, allow for the flow of electrical current. The resistance of the human body to electrical current varies greatly depending on factors such as skin dryness, contact area, and voltage. Dry skin has a much higher resistance than wet skin. This is why it's often stated that water increases the risk of electrical shock. When skin is dry, it can have a resistance of hundreds of thousands of ohms. However, when skin is wet, that resistance can drop to as low as a few hundred ohms. The path electricity takes through the body is also crucial. If current flows from one hand to the other, crossing the heart, the risk of cardiac arrest is significantly higher than if the current flows, say, from a hand to a foot. The amount of current flowing through the body is the primary determinant of the severity of an electrical shock. Even small amounts of current in the milliamp range can cause noticeable effects like tingling sensations. Higher currents can cause muscle contractions, difficulty breathing, ventricular fibrillation, and even death. Voltage is the electrical potential difference that drives the current through the body's resistance. According to Ohm's law, current equals voltage divided by resistance. Therefore, at a given voltage, the lower the body's resistance, the higher the current that will flow through it. Electrical safety is paramount when dealing with electricity. Firstly, always assume that any electrical circuit is live. Secondly, never touch electrical equipment with wet hands. Thirdly, use appropriate personal protective equipment such as insulated gloves and tools when working with electricity. Fourthly, ensure that electrical circuits are properly grounded to provide a path for fault current to flow safely to ground. Ground fault circuit interrupters, or GFCIs, are essential safety devices that can quickly detect small imbalances in current flow and trip a circuit, preventing electrical shock. These are commonly found in bathrooms and kitchens where water is present. When considering a large group of people forming an electrical circuit, it's important to understand that each person would add to the overall resistance of the circuit. The total resistance would be the sum of the individual resistances of each person, assuming they are connected in series. In a parallel circuit, the overall resistance would decrease as more people are added. However, creating a large-scale human electrical circuit would be extremely dangerous and is not recommended. The concept of the longest human electrical circuit is more of a theoretical exercise than a practical application. It highlights the conductive properties of the human body and the importance of electrical safety. Understanding the relationship between voltage, current, and resistance, as well as the factors that affect the body's resistance, is essential for preventing electrical shock.